So LEAP is a large experimental array of ponds. It's a fantastic new infrastructure that we've put here at the Gault Nature Reserve, so at Mont-Saint-Hilaire. The aim is to study how freshwater ecosystems, their biological diversity, the functioning of the ecosystems respond to environmental change. Can freshwater ecosystems adapt to environmental change? Can they evolve rapidly to deal with these stresses? These are questions that we have a poor understanding of. Up till now, we've tested the theory in the laboratory. We've used high replication experiments in the laboratory to test the theory, but we haven't done it in the field. So our goal here is to bring the 96 well plate used in laboratory experiments and to place it on the landscape. And here behind me you see 96 ponds laid out on a grid that allow us to do experiments on the evolutionary resilience of freshwater ecosystems. We've connected these ponds and this system of ponds to the lake. So we have a pipeline that runs from the ponds all the way, a kilometre away, up to Lake Hertel, which allows us to bring water from the lake and supply and fill the ponds with that natural ecosystem. So that's one of the unique aspects of this infrastructure. So LEAP is the latest installation here at Gault, at McGill's Gault Reserve, that is really becoming a hotbed for research in aquatic ecosystems. Just a couple of years ago, we established an in-lake mesocosms, which allow us to do experiments in the lake, manipulating the ecosystem in the lake. We also established a covered dome, which allows us to manipulate the atmosphere of the freshwater ecosystem in a pond. And so now we've added LEAP, which gives us 3 different types of infrastructure to study how freshwater ecosystems are responding to environmental change. And so we can study different dimensions of the dynamics of freshwater ecosystems, either in the lake, under conditions where we control the atmosphere, or under high replication when we expose these ecosystems to multiple stresses. So right now there is an explosion of interest in using mesocosm facilities like this to study how humans are impacting freshwater ecosystems. Freshwater ecosystems the world over are being affected by climate change, by pollution, by invasive species, and the idea of having highly replicated experiments like this is being used all over the world. But I don't think we have any other infrastructure in the world that really allows us to connect these mesocosms to a natural ecosystem like Lake Hertel in a way that's almost like a chemostat. We have a continuous flow of the ecosystem and its biological diversity through these mesocosms, which adds another layer of complexity and reality to the experiments that we are doing. So we have this high replication and this constant connection to the natural ecosystem, which I think is what makes LEAP unique. LEAP, we hope, is going to advance research on experimental evolution, taking the experimental evolution from the laboratory into the field. We have this high replication system that allows us to explore how different types of stressors interact, affect the biological diversity of these freshwater ecosystems, their functioning, the biomass that they produce, their metabolism, and how and if they can adapt to these stresses. Another important dimension of LEAP, of course, is the people we're going to train, the young students, postdoctoral researchers. They're going to work together, collaborate on this large experiment. Here you can see behind me that we're setting up. Quebec has an enormously fast-growing environment sector. People are concerned about Quebec's environment, the quality of its freshwater resources. We want to contribute to that part of the Quebec's economy and to train the next generation of environmental scientists.